An entity bean represents a collection of data items, and this data, taken as a collection, represents a single entity. For example, one entity bean could hold the name, address, and telephone number of a person. If you want to get the information for that person, you just call the methods of the bean. If you want to update the information about that person, you just call the methods of the bean that update the data. If you want to get the information on another person, you'll have to get another bean. Each bean represents the data for one entity. Each entity bean has a unique key that identifies it. An entity bean often works in combination with one or more stateful session beans and usually works with data from a relational database. But I'm getting ahead of myself. The key of an entity bean doesn't necessarily match up with the key in the database. The entity represented by a bean can be a combination of data from different rows and even different tables in the database. Notice I use the word represents the data on an entity instead of holding or containing the data of an entity. There is a subtle difference, but it turns out that it's a very important difference. The data will normally live in a database, and the bean just holds a copy of it for you to use if you wish. This means there are two copies of the data, and care must be taken that they don't get out of sync. The bean is said to be persistent. That means it always contains the data. If the bean exists, it holds the data, period. Looking at it from a client program's point of view, the beans hold the data. The client can read and write the bean just like it's reading and writing the database. But with one copy of the data in the bean and another copy in the database, the two can get out of phase. The truth is, the beans aren't the only things that update the database. If some other program comes along and changes the information in the database, the stuff in the bean is suddenly wrong. On the other hand, if your program updates the information in the bean, the stuff in the database is wrong. At any rate, there are two different versions of the data. Managing the persistence is the process of keeping the two in sync with one another. In earlier lessons, I demonstrated the fundamentals involved with keeping things in phase by using database locking and performing a group of updates as a single transaction. There's more than one way to set a bean up so it manages its persistence. BMP stands for Bean Managed Persistence. This is like the database stuff we looked at earlier. The bean sets up a transaction, does all of the database updating in that context. It's also the responsibility of the bean to read the data from the database so it keeps itself up to date. CMP stands for Container Managed Persistence. In this one, the container assumes the responsibility of keeping the bean and database in sync with one another. With CMP, the container does a lot more than just provide an interface between the bean and the server. It generates SQL and performs queries against the database to read and write data and read and write data from the bean. The bean exposes its internal field information to the container, and the container uses database descriptive information to match them up and keep them synchronized. When you write an entity bean, you write it one way or the other. BMP, Bean Managed Persistence, could be considered the old way, while CMP, Container Managed Persistence, could be considered the new way. CMP has some advantages. For one thing, it provides you with the ability to construct more of an object-oriented view of things. While the bean itself is in charge of everything in BMP, the CMP approach relies heavily on the implementation of the server. Different servers will do it in different ways, but most of them do it the same way as the reference implementation from Sun. And in the upcoming lessons, I'll be showing you how the Sun server reference implementation of the container is used to support data in a CMP entity bean.